Radioactive decay is a spontaneous nuclear process in which an unstable atomic nucleus transforms into a more stable nucleus by emitting alpha particles, beta particles, or gamma rays. This process is completely independent of external physical and chemical conditions such as temperature, pressure, electric field, magnetic field, or chemical combination. The decay of a single nucleus is random and unpredictable. However, when a large number of radioactive nuclei are considered together, the decay follows a definite statistical law. The rate of radioactive decay at any instant is defined as the number of nuclei disintegrating per unit time. Experimentally, it is observed that the rate of decay depends on the number of undecayed nuclei present at that moment. If a large number of radioactive atoms are present, more decays occur per second, whereas if only a few atoms remain, the decay rate becomes smaller. This leads to the fundamental radioactive decay law. According to the radioactive decay law, the rate of decay is directly proportional to the number of undecayed nuclei present at that time. Mathematically, it is expressed as dN by dt is proportional to n, where n is the number of undecayed nuclei at time t. Introducing the proportionality constant lambda, known as the decay constant, we write dN by dt equals lambda n. The decay constant lambda represents the probability of decay of a nucleus per unit time. It is a characteristic property of the radioactive substance and does not depend on external conditions. Solving the decay equation gives the exponential decay law, n equals n(e) lambda t, where n is the initial number of nuclei. A very important consequence of this decay law is the concept of half-life. Half-life is defined as the time required for half of the radioactive nuclei present in a sample to decay. It is given by T1/2 equals 0.693 by lambda. Half-life is constant for a given radioactive element and remains the same irrespective of the amount of substance present. Another related quantity is the mean life, which represents the average lifetime of radioactive nuclei and is given by tau equals 1 by lambda. The relation between mean life and half-life is tau equals 1.44 T1/2. The decay curve obtained by plotting the number of undecayed nuclei versus time is exponential in nature. This curve never touches the time axis, indicating that complete decay is theoretically impossible. These concepts form the basis of many applications such as carbon dating, nuclear reactors, medical radiotherapy, and radioactive tracers. Thus, the study of radioactive decay provides a clear understanding of nuclear stability and plays a crucial role in modern nuclear physics, making it an important and frequently tested topic in NEET and IIT-JEE examinations.